just remembering our differentiation. If that's my function, e to the power of x, how do I differentiate that? What was it? Can you remember? E to the power of x. Okay? Now, if it was e to the power of 2x or 3x, what used we do? Bring the 2 down. Yeah, so in this case, e to the power of ax, when I differentiate it, it's a e to the ax. Okay, and when we have our function a to the power of x, when we differentiate it, it's a to the power of x by ln x. Okay, now that's differentiating. Now we need to go backwards. Okay, so the integral of e to the power of x, integrate that, go backwards. What am I going to get? E to the power of x with what? Plus c. Lovely. Don't forget your plus c.
What happened to the last one? You know, the ax, what's that?
That's just your rule for differentiating a to the power of x.
Wait, so for the first one, just nothing happened?
For differentiating e to the power of x, it just stays as e to the power of x. Yeah. You've forgotten, have you?
No,
Little
but
bit.
I don't get what happened to the last one. Why did? Yeah.
That's just your rule.
For what? Where? Yeah, but where did the? Yeah, can you put a number in maybe? Just. Yeah, can you explain it with a number?
2 to the power of x
Yeah.
will be 2 to the power of x ln x.
Why? Where did the ln come from?
That's how you differentiate.
What? I'm so confused.
Okay.
Where did it come from?
It's just your rule. Don't worry about it. Let's keep going here. Integrate e to the power of ax. So that's going to be 1 over a e to the ax. Okay? You're going to divide by your new power. Remember when we're integrating, just normally we increase our power by 1 and divide by the new power. Same with this. I'm not increasing my power though because it's e to the power of ax. Okay? Rules, just rules. Don't even have to learn them off. Okay? Don't forget your plus c. And the integral of a to the power of x is going to be a to the power of x over ln x plus c. Now all of this, page 26 of your log tables.
So what's the difference in the e to the power x and the a to the power of x?
E is a number, okay? So e is just, it's like pi, it stands for a number, okay? Now a to the power of x is 2 to the power of x, 3 to the power of x, 4 to the power of x.
Is that not
Okay.
a number though?
It is, but e is, there's just certain rules for e.
Oh, like it's just going to be e, it's not going to be...
Oh, it's just going to be e. Yeah, you're not going to be filling in for e.
Okay.
Here are your rules for integration, okay? So we know x to the power of n, we increase our power by 1 and divide by the new power, okay? 1 over x, ln x, e to the power of x stays as e to the power of x. So they're all there for you, okay? Will we do a few examples of these?
Yeah.
Okay, find the integral of e to the power of 3x. What's that going to be? 1 over 3, yeah. So it's going to be e to the power of 3x over 3, or 1 over 3 by e to the power of 3x, plus your c. Integrate e to the power of 4x plus 6x. So you just integrate each one of these separately. E to the power of 4x becomes integrate e to the 4x over 4, good. Integrate 6x. Lovely. 6x squared over 2 plus c. Okay, so that's just going to be 3x squared plus c.
Why did you put it over 3?
That's what we learnt on Friday. So you increase the power by 1 and divide by the new power. Okay, when we're differentiating, we're multiplying. Remember that power comes down and gets multiplied. In this case, you increase the power and divide.
Why didn't you increase the power for the e?
That's because e has its own rules. So they're what we learnt today. Okay. So when you were differentiating e to the power of x, your power never changed. Okay, and when you're integrating, your power never changes. Integrate e to the power of x plus e to the power of minus x. Now, integrate e to the power of x. E to the power of x, lovely. Integrate e to the power of minus x. E to the power of minus x over minus 1. Yeah. Plus c. So you can leave it like that, or that's going to be e to the power of x minus 1 over e to the power of x. I know when I have a minus power, it can come under the line and become a plus power, plus c. Okay? Okay. Example 2. Okay, given that y is 5 to the power of x, show that the integral of 5 to the power of x dx is this thing. Okay? Now, in this case, they've given us the function. They've given us y. Normally, when they're asking us to integrate, they've given us the derivative and we're getting back to the function. Okay? So if I know that y is 5 to the power of x, then dy dx, if I differentiate that, differentiate it first, go in here. So a to the power of x, okay, I know it's not that clear here, sorry. A to the power of x is a to the power of x ln of a. Okay, that's how we differentiate. So here we have the function, let's differentiate it. Okay, so a to the power of x, we have 5 to the power of x, and we know when we differentiate it, it becomes 5 to the power of x ln 5. Okay? Now, they want us to integrate 5 to the power of x, or to show that this is equal to this. We have this derivative, and I know when I integrate this, I get 5 to the power of x. Okay? Because when I differentiate this, I get back to the function. That's how integration and differentiation work. It's the reverse of, one is the reverse of the other. Okay? Now, ln of 5 is just a number. Okay, it's just a constant. 1.6094. Okay, so ln of 5 is just a number. That's not going to actually change anything. Okay, so let me just get rid of this bit here. Integrating this, I know I get back to this. To integrate ln 5 or to integrate 2, it just stays as 2. Okay, so I have ln 5. I can pull it outside the integration sign because nothing happens to it. Okay, so if ever you have a constant, it can come outside the integration sign. Now, the integral of this gives me my function, doesn't it? So it gives me my function. When I integrate my derivative, I get my function. So I'm just going to put that equal to my function, which is y. Now, my question is, show that the integral of 5 to the power of x dx is something. I have 5 to the power of x dx there. Where's that ln 5 going to go? Under. Lovely. Now, what was my y? 5 to the power of x. So the integral of 5 to the power of x dx is 5 to the power of x over ln 5. But I'm integrating, so what do I need? Plus c. And now I've shown that. It is a roundabout way because we just know how to integrate 5 to the power of x. But it does often help us to, if we're given the function, we differentiate it, and then we can use that derivative, integrate it, to get back to the function. Okay, it's kind of working backwards and forwards.